A servo motor does a great job of accurately holding its position as long as it's enabled. But as soon as you disable the motor, it releases control. And that can be a problem if you need to hold a load in position like this weight or the z-axis of a gantry, for example. Electromechanical braking is ideal for applications like this because it clamps the shaft of the motor while the motor is disabled. You could also use electromechanical braking to hold the load in place instead of burning motor power to do it. It should not be used to decelerate a motor. That's what regen braking or dynamic braking are for. To use electromechanical braking, you need to buy a motor with the brake built in. When you look at a non-braking motor next to a motor with an electromechanical brake, you see the braking motor is bigger. This extra space is where the electromechanical brake is located. It helps if you can visualize what's going on, so I took this previous generation servo motor apart. This is the shaft and rotor from inside the motor, and this is the brake. These ridges grab this plate on the brake. If we remove these screws, we can see this top plate is supported by these standoffs, and it has this grippy material on the back. It feels a lot like the brake material on your car brakes. This is the disc that the shaft grabs onto. It's just free floating in here. The bottom plate also has the grippy stuff, and it sits on top of some pretty stiff springs over an electromagnet. So the springs push this bottom plate up, which presses this plate that grabs the motor shaft up against the top plate. When I put these screws in, it compresses the springs, so now the free-floating plate is clamped into place and I can't move it. If I apply 24 volts to the electromagnet, it pulls that bottom plate down against the springs, releasing the middle plate. Remove power, and the plate's clamped again. Now you can see why applying power releases the brake, and removing power engages the brake. And that's exactly the way you would want it, right? If you disable the motor or lose power to your system, you don't want your load to fall to the ground. You want it to stay where it was until power is restored and the system's back under your control. I used this previous generation 750 watt motor for that teardown because it's easier to disassemble and larger, making things easier for you to see. For comparison, here are the guts of a smaller 400 watt SureServo 2 motor. At first glance, it looks almost identical. This electromagnet pulls this metal disc away from the braking pad, which allows the motor to spin. But there are a couple notable differences. First, the shaft on the SureServo 2 motors is keyed. I love that I now have the option to use keyed pulleys. The other difference is the previous generation used this pattern on the shaft to engage a metal disc with the braking material on it. And while it worked great, under just the right circumstances, you can actually hear the metal disc rattling around in there making noise as the motor runs. The SureServo 2 motor uses this square feature on the shaft to directly engage an independent and much thicker braking disc. This gives you longer life, more reliability, and quieter operation. Okay, now that we see how the electromechanical brake works, let's see how to connect it to a SureServo 2 drive. I'm using the exact same hardware as we used in the Quick Start video, except I replaced the non-braking motor with the braking version of that motor, and I replaced the power cable with the braking version of the power cable. It has the 2 extra wires needed for the brake. I love that I have the option of buying the less expensive non-braking cable when using a non-braking motor. The digital outputs are open collector, so you would typically have a 24 volt supply going through a coilover relay, through a digital output pair to the minus side of the supply. And you'll want to install a diode to help get rid of any inductive kickback to the drive. Now make sure you get it in the right direction. Installing it backwards can damage the digital output. I'm using a solid state relay, so we don't need to worry about the diode. We'll use digital output 6 to control the brake in our demo. The output side of the relay applies power when we want to release the brake. You would also typically have any e-stop or other safety circuitry wired in to prevent the brake from releasing while in a fault condition. We'll skip that for our simple demo. You can use any relay you want. Just make sure it can handle the current needed by the electromagnet. This motor spec sheet tells me it requires 7.2 watts. We're using 24 volts, so that's only 1/3 of an amp, which means this 12 amp solid state relay we're using, simply because that's what I happen to have laying around, is massive overkill. Normally you'll want the brake to clamp the motor shaft anytime the servo motor is disabled. So when we enable the servo motor, we want to apply power to the electromagnet to pull that bottom plate down to release the brake. And when we disable the motor, we want to de-energize the electromagnet so the motor shaft is clamped in place. You can also adjust the timing of these by adjusting these delays. There's actually more to this, but this is enough to get us started. So, we'll set parameter 2.41 to a 108 to tell the drive digital output 6 is our braking control signal, and it's a normally open relay. And we'll leave the delays at the default 0. Now remember, you can always manually force an output to see if the wiring is correct. Just go to parameter 2.8 and set it to a 406. And it tells us we're in digital output force mode. And then go to parameter 4.06 to force each bit. We're using bit 6, so that would be a hexadecimal 20. And when I hit the S key, sure enough, the solid state relay turned on, and more importantly, I can rotate the motor. When I disable digital output 6, the electromagnet is no longer powered, so the springs have the plates clamped together and I can't rotate the motor. Perfect. Now don't forget to go back to parameter 2.08 and set it to a 400 to disable output forcing, or just power cycle the drive. I also set up the servo to move back and forth between two positions using the position register mode. There's a whole video showing you how to do that. Right now my servo is disabled. If I had a non-braking motor, I'd be able to reach over and turn the motor shaft right now. But because this is a braking motor and the brake's electromagnet isn't energized, it's clamping down on the plate which is holding the motor shaft still. When I enable the servo motor, the brake releases and the servo system is allowed to do its thing. When I disable the motor, the drive automatically clamps the motor shaft in place and the weight doesn't fall. Perfect. Remember this diagram? We had the delay set to 0, so things were simple. If the delay isn't 0, then the 0 speed parameter comes into play. If the system reaches this time, but the 0 speed hasn't been reached yet, the brake will clamp the motor shaft regardless of the shaft speed. So beware of that. Braking always wins. If the shaft speed does hit the 0 speed parameter before reaching this time, then the motor shaft will also be clamped. So whichever happens first, 0 speed or braking will clamp the motor shaft. Again, we had the delay set to 0, so we were guaranteed that would happen first. Now, while it's great that the SureServo 2 drive does all of this automatically for us, it does beg the question, do you have to use the SureServo 2 drive to control the brake? Nope. Anything in your system can control the brake. You just have to make sure your controller is synchronized with the SureServo 2 drive so there isn't a conflict. You don't want to have the drive trying to move the motor while your system has the motor shaft clamped in place, right? There's a really nice diagram in this braking section of the manual that shows you the timing of how the SureServo 2 system powers up so your controller will know when it's okay to release or engage the brake. Well, that ought to be enough to get you up and running with the electromechanical brake in the SureServo 2 system. Click here to learn more about the SureServo 2 system and to find more tutorial videos. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.